I already know that this is nothing else but the f of x plus dx. And we know that since last time, we know that this is approximately f of x plus f prime of x dx. So what I need to identify is the function, is x and dx. Once I identify, the rest is easy. All I have to just plug it in. So looking at tangent 44 degrees, can anyone give us first the function, then x, then dx, and then f prime of x? What do you think? Anyone? Nothing? What about the function?
Would the function be tangent?
Of course. What will be x?
44.
45.
Very good. What will be f prime? Very good. And what will be dx?
-1.
Yes, it's -1 degree, which cannot be used. Don't cross it out like that. I just want to make a point. It has to be changed into radians. This is redundant. Once we see pi, we know it's radians. I should not even write it, but I want you to understand outside of a trig function, we cannot, those formulas do not work with degrees. So if I plug in 1 degree in any trig function, it doesn't matter. The answer will be the same as if I plug in radians. But if it's outside and it will be outside of a trig function, I have to make sure it's in radians always. That's it. I'm done. I just have to
Why
put.
did we make x 45? I'm confused on that.
So when we compare these two, we realize that all we know is tangent of 45. We have no idea of what tangent 44 is. But tangent 45 is very clear because we know we have the answer for tangent 45 with no calculator. So now this must be -1 degree. So it's something plus an error, but the error may be negative as well, right? So it's something plus or minus a tiny error. So we really have 45 degrees. That's what this means. X plus a little bit. So this is the big thing, and this is a little bit, as we know. So it has to be 45 and -1. I'm not going to use 90 degrees because 90 degrees is too far away, right? So the closest to 44 is 45 that I know of. Is this okay?
I'm going to rewatch the video because I lost something somewhere. So, okay.
No, this is not related to anything. This is just how
I'm just wondering, did we just come up with 45 out of nowhere? That's what I'm trying to figure out.
It's because from trig, we know the trig function values for 0, pi over 6, pi over 4, pi over 3, pi over 2, and so on and so forth. And this is one of them, 45 degrees.
Okay, so we just grab that to grab it. Okay.
As long as this is the big chunk and this is tiny, not the other way around.
Is there any way we would ever think about grabbing something else like the pi over 2 or anything like that, or we're just grabbing it because that's close?
But pi over 2 is 90 degrees, and the distance.
But would it still work?
But the distance between 90 degrees and 44 degrees is not tiny.
Okay, I understand.
So this has to be the big chunk. So let me go back. It's a good question. So when we discovered this relationship, we said this is tiny. In other words, Q is here. Now, if I have here 90 degrees, this is not tiny. Or if I have 40 degrees or 45 or 55, this is not tiny anymore. Q is close to P, so delta X Has to be an error, not the chunk, not the big number, but the error. Because then these are too far apart, and I cannot approximate anything here or this distance if this tangent is, if Q is not close to P. I will not be able to approximate this distance with this distance.
So we're going to say the error is always small would be a good assumption.
But that's what we say. We call it a small change in the independent variable.
Okay, I understand. I'm used to things that are sometimes small errors and large errors. So I'm just making sure. Okay, thank you.
Thank you. So the error is what we call an error. So if we have $100 and plus or minus 99, this is not an error. We say $100 plus or minus, I don't know, $1 maybe. So this will be the error. So it's like a tolerance. So the tolerance is plus or minus, something tiny, 0 point whatever. Otherwise, we cannot approximate. So if this is not small, this side would not be approximately this side, would be totally different. The difference will not justify the calculations. So let's go back then. So I'm here. So tangent 44 degrees, approximately. Can anyone give us this side now? Anyone? We identified everything. We just have to put them in now.
Approximately tan x, so tan 45
Exactly.
plus
Yes.
Yeah.
Very good. Secant square 45 times. Excellent.
Times dx, so dx is negative pi.
That's it. That's all I want you to say. Done. So then, now this is equals. This is 1, as we know. So this, if you remember, secant is 1 over cosine squared, right? So 1 over cosine squared, and cosine is the square root of 2 over 2, or 1 over the square root of 2. When I flip it, I get 2. Okay? So, and square it. Flip it and square it. So times negative pi over 180. So then I'll simplify. And then I have 90 minus pi over 90. So now I'm going to share my screen to see where's my calculator right here. So clear everything else. So we have tangent 44. Make sure that the mode is in degrees when you plug in 44. Okay, so now I want tangent 44. Where is my tangent? Right here, 44. And don't forget parentheses for the top, 90 minus pi. Pi is right here, this key here, the caret with a second, divided by 90. Pretty good. You would have never, ever believed that tangent 44 is the same with 90 minus pi over 90. Very close. Why? Because dx is small. Good. Okay, so let's go back to other problems. So everything we did last time, I remember 32. Okay, before we look at anything else, is there anything that catches your eye here? Finding dx dy or delta y dy.
Do 20.
Okay, where is it? Let me see. 20, very good. So we have in 20 y equals cosine pi x. Do we have x equals 1/3? We have dx equals negative 0.02. As expected, dx is tiny. Let's see what they want. Find the differential, evaluate dy for the given values of good. So remember, as we said, there are two different things. Please do not confuse them. Derivative of f of x, differential of f of x. Two different things. The derivative is f prime. The differential is dy equals f prime of x dx. Do not confuse these two. Okay, so they're asking us to find dy. No problem. Dy equals, can anyone differentiate this for us?
Negative sign. Sure, yeah.
Very good. Times, so I have this, times
Negative.
times, I want everyone to understand that this is dy. So we differentiated the function, but I have to multiply by dx. If I don't multiply by dx, I'm not getting the dy. Is that clear, everyone? Yes, no, anybody? Any questions?
Real quick, so why can't you use the dx that it gives you in the problem?
I didn't plug in any numbers yet.
Oh, okay.
I didn't plug in any numbers yet. First, I have to find dy. Is it clear why this is dy?
Yes.
Perfect. Now, I'm determining it. dy equals negative. Let's put pi in front. Pi. Sine. Pi times x. Pi divided by 3 times dx, which is negative 0.02. So dy, so sine pi over 3, can anyone tell us? So this will be 0.02 pi. How much is sine pi over 3? Anyone? We did this a month and a half ago.
Is it pi square root of 3 over 2?
Excellent. So then when I simplify, I get it 0.01 pi, 0.01 pi the square root of 3. If you write this as dy, I cannot give credit. dy is f prime of x dx. Please remember this. Good. Anything else? Or we are ready to finish up with linearization and linear approximation. That's the last
Sorry, you
topic.
said you won't give credit for what?
If you write dy as this,
What's on the other side of the pie? The thing you covered.
that's my point. If somebody writes the dy is this without times dx, I cannot give credit.
Okay.
Sorry, you cannot see. I see why you cannot see. Okay?
Yeah.
So if somebody considers dy being this without multiplying by dx, I cannot give credit for that.
So if we were to skip the line where dx is in orange and go straight to the step where dy equals the actual numbers without writing the formula, but we inserted the numbers properly, we would lose credit for that?
So you are saying that you can write this without writing that?
Right. If we did, for instance.
then I will say that you copied it from somewhere because you can't.
Okay.
I mean, can I fill it in to my students and say, hey, this is dy, without showing how I got it?
Gotcha.
You understand? This is a mandatory step. You have to show this, because if you get here and you omit something, then I cannot give any credit again. So if from here you miss something, at least you know that you know what it means. You know how to determine dy. But if you do not write this and you plug in the numbers and you forget a sign or you forget something, then the partial credit is much lower. So maybe you can, by simply looking at this, come up with that. Maybe you can. I will not do that. I have to explain how I got it, and then plug in each and every thing that I'm given. But I would not skip this step. No one will understand what I'm doing. I mean, where do I get this if I don't show how dy is determined and then plug in each and every one? That's my suggestion. Okay, next. So let's go back. Oh, no, I'm not going to share just yet because I want to talk about the linearization and the linear approximation. Okay, linearization and linear approximation. What is all this? Well, bottom line is this. We have a function, and we have a point on the function, point P, and any function at any point can be approximated by a line. Near that point, near P, f of x can be approximated by a line. Which line? Of course. What line is this? What line did I just present?
It's the tangent, or also known as differential.
Very good. So near P. Near P means not here, but here. Near P with any x, near P, a little bit of error this way and a little bit of error this way. It doesn't matter if I evaluate the function or if I evaluate the line. I will get a very close approximation, very close number. Yes, if I want exact, if it's a matter of life and death, I want exact. I'm not going to use an approximation. But if I'm okay with tiny error, I can use the line to approximate the function or get the function values very close to P. What if I want to approximate here? No problem. I will determine another line for that point, but not this one, at this one, near that point. What about approximating here? That's fine. I will draw a tangent here. I will find this line, and I will say this line approximate at Q, near Q. Different line for every point, unless it's something very close. Tiny error one way or the other. Okay, how we do that? So we will determine, so let's say P has coordinates a, f of a, this point, or this point, or this point, it doesn't matter, any point. So I want to find the tangent at P, the equation of the tangent at P. How do I do that? I use y minus y1 equals the slope times x minus x1. I will have a, which is x1. I will have f of a, which is y1. And now, with all the experience you have, you will tell me what m is. What does m equal to?